What is up, my Twin Tower students? Today we are going to be working with some robotics challenges. We're going to be doing some asynchronous Friday challenges. We're going to be doing two things that are due today. I'm going to give you the first little, I'm going to give you I get a model, I'm going to give you a demonstration of like the first step you have to do. And I'm going to explain how to build on top of that to finish the challenge. I give you a lot in these videos, so please try to, follow through, see what I do, understand the steps, and build on top of them to complete these challenges on your own during Asynchronous Friday. Most of us finished Square Box Challenge in class, so I'm just going to go over Mower Challenge to start with because it's what most people need. But if you do need Square Box Challenge, I'll probably have that at the end. So maybe you could skip through the video bit and find Square Box Challenge. As always, if there's something you don't understand, there's something you don't understand, like there's something you need to see again, it's a video. Back it up 5 seconds, watch it again. Let's start with this Mower challenge. So we talked about this in class, but we need our robot to cover this entire field. And we need to do it using our gyro sensor for turns. So let's see. When the program starts, so we need to clear all these green tiles. We need to cut all this grass, is the idea for the Mower challenge. What should our first step be? I think for our first step, we could do something very simple. We could just go straight. So there's a lot of different ways to go straight, but we want to go straight a set distance. We just want to go straight from here to here. I think that we can just go a certain amount of rotation straight. Let's try 2 rotations. Okay, it's cutting some grass. Oh, it doesn't go far enough. Let's try 2 got us here. Another 2 will probably get us here. It's 4. Another 2 will probably get us like here. Let's try 6. Let's see how 6 looks. We want to always try and iterate on our code until we finish our steps. And each time we finish a step, this is a little far. Maybe I'll try 5.5. So this first step, we just want to go down this row. Okay, that looks pretty good. I'm liking this so far. So we've completed our first step. That's what you always want to do first. You want to go step by step. You want to make sure, okay, the robot did the first thing right. Now let's look at the next thing. Okay, he did the next thing right. Now let's look at the next thing. So our first step is just to drive straight. I've seen all of you do that before. It shouldn't be an issue. I know all of you know this already, so I'm more than happy to let you guys see this. Okay. Now here comes the tricky part. We need to do the thing we learned this week. We need to make a right turn with our gyro sensor. Once we get to this point, we need to turn 90 degrees so we can get into this row over here. Once we're over here, we need to turn 90 degrees. We need to do 2 90-degree turns to the right. How do we do 90-degree turns with the gyro sensor? Well, first, let's make him start turning to the right. Let's have him turn the right direction. We'll have him just turn forever in the right direction. In literally the right direction. He'll literally be turning right forever. And then we'll have the gyro sensor tell him to stop turning once he's facing the right way. So the way we turn right is we use this moving block, and positive numbers make us turn right. So let me see what happens if I try turning right 10. So let's start moving right 10. I forget what that does. Let's try it. Right 10. Oh, okay. That drove me off the table. He was going a little bit to the right. You can rewind the video if you want to see it again. I'll do it right now. He's going a little bit to the right, but he's still going way too far straight. Whenever we make our right turns or our left turns, I always want our steering values to be 100. That'll make sure that our robot is staying perfectly in place. He's not moving. He's focused all his energy on just making that right turn. So now our robot has 2 steps. We've done 2 steps. We've made it to the end of this first path, and we've told him to start turning right. But he's a robot. Once you tell him to start turning right, he doesn't know when to stop. We could tell him, stop moving. We could just immediately say, start moving right and stop moving. But now he's not going to turn at all. Because we told him to start moving right, but we immediately told him the next block to stop moving. We need some block in between this that decides when he should stop moving, that decides when this next code block should run. And that's going to be our sensor. As we know, our sensors are these light blue blocks. This light blue code is all for controlling our sensors and letting our sensors control what block comes next. Our gyro sensor can see angles. So we can click this button here, 0 degrees, and it'll show us the angles of our turn. So if I have this button open and I start turning, it'll show me what angle I'm facing. Every full circle is another 360 degrees. We want our robot to stop turning once he's turned 90 degrees. So we can use our gyro sensor blocks, which are all going to say the word angle in them, because gyro sensor always has to do with angles. And we could see once the angle has changed more than 90 degrees, we could stop turning. Let's see if that gives us our 90-degree turn. So we're going to go straight, we'll start turning right, and then once the angle has changed 90 degrees, we'll stop moving. Let's see. Uh-oh. Okay, this looks pretty good. And maybe we could even get it to work doing this turn. But there's a problem. I turned a little bit too far. I wanted to turn 90 degrees, but my robot has turned 94 degrees. Huh. What we had talked about in class is that our robot follows his instructions. He sees that my angle has changed more than 90 degrees, and then he stops moving. But it takes him a little bit of time, just a little tiny bit of time, to run this next code block. He realizes that 90 degrees happens. It takes the sensor a little bit of time to realize that he's turned 90 degrees. It takes the sensor a little bit of time to send that message to the main robot's body. The sensor's up here. The main robot's CPU, his brain is over here. It takes a little bit of time for the sensor to tell the brain we've turned 90 degrees. It takes a little bit of time for the brain to say, okay, let's move on to the next block, and then run the stop moving block. And then it takes a little bit of time for the stop moving block to tell the wheels to stop moving. And all those little itsy bitsy microscopic pieces of time, all those little itty bitty milliseconds, end up making it so that he turns a little bit too far. How can we fix that? Well, in class today, Ariel had given me a really great suggestion. This isn't a suggestion from the textbook, but it works pretty well. Is we see that we're getting an extra 4 degrees. So he said maybe try just stopping once we reach 86 degrees. So let's try that. I think that actually worked pretty well. Okay, so we try stopping at 86. We're a little laggy, and he turns a little bit too much still. Maybe we'll try 85. Let's see if we can get right on the money. Oh, now he's turning a little too slow. This still is a little inaccurate. It's better. It's a good strategy. And maybe I'll use 89.6 or something. Maybe that'll get me a little bit closer. But I don't want this weird variance to my turns. I don't want to have to worry about, all these extra factors messing up my turns. I want to do an exact 90-degree turn. What can really help with that is that if the robot is going slower right before you start turning, if we go a little bit slower, a lot of bit slower, then he could do his turn more accurate. So he's going really slow on this turn. He's being really careful, really methodical, making sure he doesn't miss the mark, making sure he doesn't overshoot it. And he overshot it. Why did that happen? What did I do? I did something wrong. I told the robot to start moving right. I see. The decimal doesn't work. The decimal doesn't work. It looks like we can't use decimals on this block. Yep. that was it. Okay, so let's set this back to 90. So now he's doing a very slow, very methodical turn, and he's going to stop exactly on 90. Since he's going so slow, he's taking his time, he won't overshoot the mark. And now that we've gotten a nice 90-degree turn, what we'd have to do next is we just have to move forward to this next square. So let's try that next step. Let's see what that would do. Uh-oh. When I tell my robot to move forward to this next square as my next step, he's still going way too slow. He's still going really, really slow. I think we're going to have to reset the speed. I think for turns we can go slow so that they're accurate. But when we're moving, maybe before each move forward block, we could set the speed a little bit higher. We don't need to be accurate on how far forward moving. They're pretty big blocks, you know, as long as we're within a decent measurement. It's going to be slightly inaccurate if we're going really, really fast. So I'm going to keep a reasonable speed. I'm going to go with 75% speed for things like this. Still pretty fast. He's making good progress. But he doesn't overshoot his mark or anything. He does this very slow, methodical turn. And he gets to the next spot. What you guys need to do is you need to do the same process. You need to continue it. So we're going to need another turn. We're going to need another turn right at the end. You're going to have to add another one of these gyro turns, a 90-degree turn. Then you're going to have to add a move forward to the end to get to this. Then you're going to have to add a left turn once you get over here. Left turns are the same as right turns. We're just using negative numbers. You're going to set the movement to a negative 100 for turning left. And we're going to check the angle is turned negative 90 for moving left. Let's do a left turn right now. I think that you guys, using this information, should have no problem finishing this challenge. Here's some early code to get you started. You should try to do it step by step and understand what each code block kind of does. And just so you know, we have kind of these separate segments here. You're like, what is happening? So this first part moves us up. This next step does our turn, and then this next step moves us again. Knowing what each of these does is going to help you continue through more steps. In a future step, you're going to have to turn left. Once you reach over here, you're going to have to do a left turn, and then another left turn. Let's look at left turns. There's another challenge that you guys have to have done today called the square box challenge. A lot of us finished this in class already, but some of us didn't, and that's okay, because we have asynchronous Friday to finish it. Left turns are very similar to right turns. The only difference is that we're going to go negative 100 for our steering value, negative 100. And to stop, we're going to check if our angle has changed more than a negative number. So if I wanted to turn left, let's say I wanted to make a 180 and turn around, I would check for negative 180. I'm just going to do, because I don't want to finick with it, I'm just going to try negative 176 because it'll be close enough. Full speed. So now I'll turn 180. What you need to do for this challenge is you need to move forward, start turning left, turn 90 degrees to the left, and then repeat that process all the way around the box. The same steps. Move forward, turn left. Move forward, turn left. Move forward, you win. Turn left. If anyone has a hard time with this, I'll be available on Asynchronous Friday to help. I'll be available for video calls as well. I know some students maybe need more hands-on stuff. Please let me know if you need anything. Even if you're watching this video later than Asynchronous Friday or another day, my emails are always open. We can find a time, and I'll help you out. That being said, good luck on your robotics work in the future. have a great weekend. See you later, everybody.